The focus of this video is on debugging in Visual Sim Architect. Now, Visual Sim Architect has many available resources for debugging your system level design. These resources include performing parameter level syntax checks to make sure all of your parameters have been properly specified in the correct syntax, debug and error messages with built-in recommendations so that when your system level design is running and there is an error, there's a lot of information about what that error is and tips on how to fix the error. We have a library of plotters and text displays for the monitoring of data in your design as well as on the output of the design. We have the ability to listen to a number of elements such as blocks, listening to the simulator, state machine, and ports. We have the ability to perform profiling of the virtual machine script and the simulator itself. We have the capability to animate the simulation, to set breakpoints, and to highlight blocks. Now I'm going to use the following flow control system to illustrate some of the resources within Visual Sim Architect that can be employed for debugging purposes. Now this design is a general flow control one which takes in data from the left-hand side, the traffic source generators, which generates transactions and are eventually sent to these blue blocks, which are queues, or more specifically smart resources. And these smart resources are used to enable or execute flow control so that the egress queue at the right-hand side isn't overfilled. Now, one of the capabilities or resources is to animate the simulation. So when I run the simulation in animated mode, you can see that the different blocks that are executing are highlighted. And this is useful, especially at the beginning of developing your system, to make sure that the blocks are firing in the perceived order. Sometimes if you find that certain blocks aren't highlighted, that could indicate an error, because certain data isn't getting to certain parts of the system. Another important debugging resource is the ability to, let's say, on a given input or output port, listen to the port. And what that does is it brings up a window that when I run the simulation, I'm able to see the transactions that are going over that particular port. And this is something you can do very early in the design process as well as any other stage of the design process. And the nice thing about that is it allows you to in a very flexible way look at the transactions that are coming into a port or going out of a port in your design. Another possibility is that you can specify breakpoint. So if I want to say stop on entry to a given block, which is the smart resource, and I run the simulation, we see that the breakpoint is hit on the smart resource, and if I want to continue, I hit continue and it's hit again. And to remove the breakpoint, I can just simply remove that and continue execution. Finally, let's say I want to look at the execution of one of these script blocks. The script block is one in which you can specify in a C-like language an algorithm of various sorts or a particular control-oriented implementation. And let's suppose what I want to do is I want to look at the block as it's being executed. So I'm going to do a listen to block, and I'll run the simulation, and I can see in this window the execution of the block. For example, it says that at time 9.03 there has been an event fired. And then for each statement in the script, it's giving you the expression as well as the result of the expression. And this is a way that you can monitor for a given script what is happening, both in terms of the expression that's being executed as well as the result of the expression. And of course, you have the ability to have the plots. These are the plot objects. This one is a text display. This one is a graphical plot for latency. If I were to turn those on, I had them off earlier to focus on some of the other debugging resources, but let's turn these back on. And then let's run the simulation. Then what happens is that the plot objects show or indicate the data that is being sent to it, either in graphical form on the left-hand side or in textual form on the right-hand side. So on the left-hand side we have the latency for the transactions. We also have a latency histogram, and on the right-hand side we have the statistics for the queues and other elements, and on the lower right-hand side we have the transactions that are being sent out. So through the use of the resources of the library plots and for graphical and textual plots, and through the resources of breakpoints, animation, listen to port, listen to block, you can basically put together a very powerful debugging implementation such that you're able to remove errors in your design and quickly converge to an optimal design. This concludes the video on debugging in Visual Sim Architect.